way back in time. So in the previous sections, we were working with data that was collected by scientists that were using instruments and just collecting data and recording it. But we can use ice core samples that will give us data about the Earth's atmosphere and the environment from times before humans were even walking on the Earth. So if we read this, go ahead and read this introduction. Also, we'll read this picture caption that says the section contains 11 annual layers with summer layers arrowed, sandwiched between darker winter layers. And remember, an annual layer just means that 1 year has passed, with the summer layers being lighter in color and the winter being darker. So question 13 asks, why do you think the winter layers are darker than the summer layers in the ice core? So these ice cores are taken at very high altitudes in places that commonly will receive snow year-round. The reason why we see light colors during the summer months is because there's a lot of evaporation happening at lower latitudes, which is causing moist, warm air to enter those higher latitudes and eventually fall. So we're actually going to see high amounts of fairly clean snow falling during the summer. And in the winter, it tends to get a little bit less snowfall. And since there's a lot of dust circulating at those times, the winter that's falling seems to be a little bit dirtier, not as clean as those high amounts of precipitation that we get during the summertime. In section 6, we're going to be taking a look at more data from an ice core from Antarctica. So here we see again the temperature compared to the modern average on the y-axis, and on the x-axis we see the years before present, with the most recent times being at the leftmost side of the graph. And as we move to the right, we're going further back in time, which is beyond 400,000 years in the past. That's how much data that we can get from some of these ice cores, just because after this snow and ice melted, it was compacted and it just stayed in that core for us to collect it later on. So question 14 says, the trend in the graph shows short warm periods between long periods of highly variable cold climate. Which statement is supported by the information? The graph shows that the temperature for the past 10,000 years compared to the previous 400,000 years has been what? So if we were to look at this data over here for the past 10,000, right? So if you figure this would be about 25,000 years in the past, about 10,000 years in the past, we're just looking at this little sliver of data over here, and we're comparing it to the previous 400,000 years over here. So if we're to look at the trends in the past 400,000 years, definitely very variable, with most times being lower than that modern average. But if we were to look at this slice here, it looks like those temperatures are right around that 0. So to me, it pretty much looks like they are staying fairly stable, according to this graph over here. And that's just looking at the past 10,000 years. Previously in this interactive, we've really only been looking at climate data for the past about 150 years. So just kind of keep that in mind when just comparing these two different pieces of data that we have. Let's take a look at what we have next. This is our favorite line graph again. Let's see what we're going to do in this section. This section is predicting the future from the past. You have just seen these graphs. Use these graphs to describe how current climate trends, which is the first graph, might change the pattern of warming and cooling seen in the Vostok ice core, which is the second graph. That's the one that we just looked at. So the question here is asking, describe how current climate trends from 1880 to 2019 might change the pattern of warming and cooling shown on the Vostok ice core graph. So when we're looking at this ice core graph, we kind of see these very variable changes from a little bit warmer than average, and then many, many years of temperatures that are much cooler than average. So if you look over here, anything below this line is less than 2 degrees below the global averages. I think the caption before said that any temperature that's below 3 degrees of the global temperature would be an ice age. So how might this line graph, this upward trend in temperatures, affect this very variable set of data from the ice core? Well, I would say that if we continue seeing an increasing amount of temperature anomalies like we do in this graph, then we can expect, rather than seeing this drop off of temperatures, we can expect this global temperature to increase and break that trend that we see over the past 400,000 years. In this last section, looking to the future, one of the more important things to consider when looking at this graph is that the Earth is a complex system. And when climate scientists are making predictions, they can't just look at temperature. They're going to be needing to look at a number of different things in the Earth's system that could potentially have an effect on global climates. So it says here that scientists design their models to focus on just a few of the components at a time. And the result is going to be a number of potential scenarios based on these computer simulations that are paying attention to different sets of variables. So when we're looking at question 16, the last one for this interactive, it asks, explain how scientists can be both fairly certain that the Earth is warming and still actively researching the unknown factors. So in this activity, we did look at that upward trend of increasing global temperatures from especially 1880 to the current year. So that's how scientists can be pretty certain that the Earth is warming, just by looking at the data that we have, comparing that to the ice core samples that show global climate change over the course of hundreds of thousands of years. And this last part, they're still actively researching the unknown factors. So as our technology gets better, we might be able to make more discoveries. As we have more evidence, we're going to be able to paint a clearer picture as to what might be happening. And as more people are paying attention to this and studying this, they might be able to look at data in different ways and make better predictions about what's going to be happening to our global climates. So that's it for today's activity. I hope you found this video helpful. Have a nice day, and I'll see you next time.